2, 1, here we go. All right, recording. So if a parabola has a focus at negative 2, 3 and a directrix at y equals negative 3, find the equation in that form. Just by looking at the form, we know that this parabola opens what? Vertically or horizontally? Vertically, good, because the x is squared. That's the familiar one. That's one we're used to. That's the function of x. It passes the vertical line test. We need to see if it opens up or down. And to do that, we plot our points. So we just make a quick little sketch here. It doesn't have to be anything too elaborate. Y-axis, x-axis, negative 2, 3. Okay, that's going to be the focus. I'll even write that over here, F at negative 2, 3. It kind of helps me keep track of things. F for focus. The directrix is at negative 3. So that's down here at negative 3. And it's going to run like this. How do I know it runs horizontally? Y equals. Very good. That's the horizontal line. Now I have the focus. I don't have the vertex. Everything we did yesterday, we had the vertex. Where's the vertex in relation to the focus and this point down here on the directrix? In between, how far in between? Exactly in the middle. Yeah. So there's a couple ways you can do it. You can find the midpoint, or you could just say, how far is it from negative 3 to 3? It's 6, right? And what's 6 divided by 2? 3. So I would have to come down 3 units to get to the vertex from the focus, or go up 3 units from that point on the directrix. And there I have my vertex. So my vertex should be at what point? Negative 2, comma, 0. Okay. So all I really need now for the equation, because this is my h and this is my k, is I need p. I need the focal length. I need the directed distance. Well, I know that this distance is 3, and I know that this distance is 3. And if you want to draw the parabola, it looks like that. It eats the focus. That's fine too. But we really don't need that for the equation. Is p 3 or negative 3? It's positive 3 because it opens up. So remember that. If it opens up or to the right, those are the positive directions. P is positive. And if it opens down or to the left, P is negative. Those are the negative directions. So now we just drop it into the form. So we get x minus h. H is negative 2, so that becomes plus 2 squared equals 4 times P, which is 3, times y minus 0. So that's what we call the conic form. But now we always look to simplify. We're not going to expand x plus 2. We're going to leave it squared. But there's a couple things we could do, right? 4 times 3 is obviously 12. And then y minus 0 is just y. So this would be the answer that you would have on a test or a quiz or something like that. That's the simplified conic form. All right, cool. Questions on that? As long as we know 2, we can find the third. In this case, it was in the middle. All right, let's go to the notes then. Try to make up for lost time with those announcements and the Pledge of Allegiance. That's good stuff. I'm glad we did that, but it cut into our note time. Oh, 5th period. Okay, we're on example. I think we only have one to go here, right? Yeah. So this one is a graph of a what? We know this is going to graph as a what? A straight line? A parabola. How do we know it's a parabola? It's got an x squared. Okay. So I can get a couple things. This is standard form, if you remember. Standard form is descending order of degree. X squared, x to the first, constant. So from the standard form, we can do certain things that we can do maybe not in other forms. Like in this form, we can easily find the end behavior. We can easily complete the square. And we can easily tell if the parabola opens what? Up or down? Up. So from this, we can tell it's a parabola that opens up. That's about all we can get from standard form. It's a parabola that opens up. Okay? Let's write that down. We know that this is a parabola, and we know it opens up. And that's from standard form. It's a very presentable form. It looks mighty. It looks majestic. There's no parentheses there. It's just a good solid form, all right? If you present your answer in standard form, it's a nice solid form. But we want to get it into conic form. So before we can get it into conic form, we're number one, we have to get into vertex form. And how do we get it into vertex form? By completing the square. Now, we had a few people in here yesterday after school working on completing the square. We did 1, 2, 3, 4. We did at least 5 of them on the back board. I left them up there. And we worked until we had a pretty good firm understanding of it, didn't we? We felt better at the end. So if you ever want more practice, come see me before or after school. We'll get you more practice, right? We'll do it until you feel comfortable. We complete the square by saying, all right, I have an x squared term and an x term. We only complete the square on the variable terms. So we have to make sure that the coefficient of the squared term, which is called the leading coefficient, we need to make sure it's a 1. Right now it's not a 1, it's a 4. So I factor out that 4 from both the squared term and the non-squared term. So what do you get when you factor a 4 out of 4x squared? You get x squared, right? What do you get when you factor a 4 out of a 24, though? Plus 6x. And that's the first error that people make. They don't factor it out of the second. They just put plus 24x. That's not good. Now, inside, we're just form setting here. We set a plus blank, close parentheses, plus blank, and plus 2. So once we factor out the 4 from the first two, it's just setting a stage, right? That's all we're doing. Now we focus on the second step of completing the square. We look at the linear coefficient inside the parentheses, and we're going to use that to decide what to add inside the parentheses. And how do we do that? Half squared, half squared, half squared. Half of 6 is 3, 3 squared is 9. So if I put a 9 there, do I put a 9 there? No. Do I put a negative 9 there? Ha! No, because I didn't really add a 9, did I? I really added a 4 times 9 if you distribute it back out. And what's 4 times 9? I really added a 36. Now, in order to not change the problem, I need to make sure I'm adding a 0. So whatever that number is, which it could be positive or negative, depending on what you factored out, I have to put the opposite of that number. So here I'm going to put a negative 36. All right, now I can factor it. I keep the y equals all the way down. Don't forget that. The 4 goes along for the ride, and the bubble turns into a bubble square. Now, it's real easy to get what goes in here. It's the square root of the first, which is x. It's the middle sign, which is plus, and it's the square root of the last, which is 3. So square root, sine, square root. Square root, sine, square root. And the whole thing's squared. Okay, square root, middle sign, square root. Some people are just bringing down the 9 and saying it's x plus 9 squared. They're not taking the square root of that last one. And then these two guys, they just kind of get together, and in this case, we end up with minus 34. So not real pretty. But this is vertex form, okay? So we can get more information from this one than we can from the original. From this one, we know that it's a parabola, of course. It's still x squared. We know it opens up because we got a positive 4, but we also know the vertex, don't we? Where's the vertex? Negative 3, negative 34. Yeah, we couldn't get that from the standard form. So that's why we like vertex form. It gives us something that we can work with. In fact, if I want to sketch this dude, let's sketch this dude. Negative 3, negative 34. I can do something like this. Here's negative 3. Here's negative 34. I'm not going to draw 34 little marks. Okay, I'm just going to say that's negative 3, negative 34. And we said it opens up. So it looks something like this and something like that. We couldn't get even that accurate from the standard form. But from the vertex form, we get the most important point on the parabola, which is, in this case, the local minimum, the vertex. All right, now, it's a short stone throw away from vertex form. I'll write that right here. This is vertex form. It's real easy to get to the conic form. Let's review the conic form. Okay, in this form, we want this one right here because it opens up. So I want to isolate the x squared. I want to get the x squared term by itself and everything else on the right-hand side. That's my goal. It's just algebraically manipulating it. So let's come down here. And I want to isolate this piece right here. Isolate it. So what would be the first thing I would need to do to isolate it? Well, I have a minus 34, don't I? I need to bring that to the other side. So that's going to be a y plus 34. And that's going to equal a 4 times x plus 3 squared. All right, that got the term isolated. Now I got to get rid of the 4. How do I get rid of the 4 if it's currently being multiplied? Divide. Now, if I divide the right side by 4, it divides out and goes away, but I would end up with y plus 34 divided by 4 on the right side. And I don't want it to be the whole thing divided by 4. So I'm going to do it a different way. Dividing by 4 is the same as multiplying by what? 1 over 4, right? The reciprocal. If you multiply by 1 over 4, that's the same as dividing by 4. I'm going to actually show that step because it's an important enough step. I'm going to say multiply this by 1/4 and multiply this whole side by 1/4. Now what happens to the 4 on the right-hand side? They divide out, and I'm left with x plus 3 squared, which is what I want. I'm going to put that on the left-hand side. And then here's why I wanted to multiply by 1/4 instead of dividing by 4. I'm left with 1/4 in front, and then y plus 34 like that. That right there is your conic form. We get everything we got from vertex form, don't we? We still see the vertex. Do y'all still see the vertex here? We have to be careful when we grab it now because both the x and the y are inside the parentheses, so they're both the opposite of what they appear. So the vertex is not at 334, it's at what? It's at -3, -34. They're both inside parentheses now, so they're both opposite of what they appear. -3, -34. But we also get this right here. That 1/4 is very, very important because in conic form, remember, the coefficient of whatever is not squared, in this case 1/4, it is equal to 4p. It is equal to 4p all the time. And once I set it equal to 4p, I can solve for p, which is my focal length. So if I divide both sides by 4, or multiply both sides by 1/4 again, that's another good opportunity to do the same thing we did up above. Instead of divide by 4, multiply by 1/4, and we get p equals, what's 1/4 times 1/4? 1/16. Yeah, very small, 1/16. That's your focal length. And because it's positive, that means it opens up. Now, what does that mean? That means I'm going to come down here to -34, and if I go up 1/16, I get to this point right here. And if I go down 1/16, this would be plus, this would be minus 1/16. I get to this point right here through which the directrix will pass. Okay? And that -3 is right here. It lines up right there. Okay. Now that's not a really nice number. Okay? So let's go ahead and see if we can answer as many questions as we can. I don't understand the first two, how they're different. So on the top row, it says direction. What is direction? Up, right? And the next one, opens. Up. I didn't make these notes. I'm just using them. I think those are asking the same thing. Okay? So we'll just put up, up. It's a double up. Vertex. We know the vertex, right? It's still at -3, -34. -3 and -34. The axis of symmetry, let's see what that is. That's that imaginary vertical line, in this case, that runs through the vertex. And because it's vertical, it's x equals, and what's the x coordinate? -3, good. The domain, oh, that's a good question. We haven't been asking that on the others. What's the domain of all parabolas? All real numbers. And you can always put the double bar r. That's fine, the double bar r. And the range, I'll use the set notation. It's the set of all y such that y is what? If the lowest point is -34, greater than or equal to -34. There you go. Or if you like interval notation, it would be y epsilon, beefy bracket -34, comma, infinity. Now notice there are two things that are missing from this list that we need to add. It's not asking us for the focus, so we'll add it ourselves. And it's not asking us for the directrix, which we'll add ourselves. And the reason it didn't ask these, I think, is because the 1/16 is an ugly number. But we'll deal with it. First of all, the focus, being right here, has the same x coordinate as the vertex, right? So I know the focus is going to be at -3, comma. Now, what's the y value going to be? Let's just think about how we're going to get the y value. The y value of the focus right here is -34 plus 1/16. Would you agree? -34, that's the low point, and then I go up 1/16. Here's how I'm going to write it. I'm going to write it as -34 plus 1/16. Are you okay with that? I'm okay with that. That's an ugly number, isn't it? And if you had your calculator in front of you, you can type it in, -34 plus 1/16, and hit enter, and it'll give you a decimal. And you can even hit math, enter, enter, and convert it back to a fraction. I know y'all can do that. We're not testing over that. We're testing over ideas right now. It's negative 34, and we go up a 16th to the high point. That means the directrix, which is a horizontal line of the form y equals, has to be y equals what? Negative 34, and now I do what? Minus 1/16. Good. So now I'll say negative 34 minus 1/16. And I'll leave it like that. If you had a calculator, you could type that in and get a decimal. I'm not interested in the decimal. I want you to understand what we're doing. The focus is up, so it's plus the focal length. The directrix is down, so it's down the focal length. And that's it. Okay? That was a good problem. We went from standard form to vertex form, and then vertex form is very, very similar, almost the same as conic form. Each time we go to a different form, we can extract a little bit more information out of that parabola, can't we? A little bit more information every single time. Okay, and just to remind you of the cool properties of the parabola, tonight at the game, if there's a guy on the sidelines with the parabolic microphone, right, and he's standing on the sideline and he's focusing it at the other team's huddle, he's going to be able to intercept their plays, isn't he? And that could give the unicorns an advantage, right? Parabolic microphone. Would that be cheating? I don't know. Parabolic microphones are allowed on the sidelines. I'm not sure if UIL allows them, but they're allowed on college football games. So anyway, that cool properties that of the reflective properties that is of the parabola. All right. Oh, and if we work it in reverse, remember your headlights. One single light in all directions concentrates everything in a parallel beam. I love the word beam. It's a focused, concentrated, singular, unison beam. You got to love that parabola. Any questions on the parabola? All right. You have a quiz tomorrow over chapter 4, right? It's all of chapter 4. There is a review that I activated this morning in Canvas. Let's take a look at that real quick. The review in Canvas. Where is it? Let me refresh here. It says review for chapter quiz grade. All right. This is not going to be due until we take the test next Thursday. So this will be due Thursday morning. I need to put that in there. I'll put that in there right now. Or I think I have it in there, don't I? It's due at 9 a.m. on Thursday, the 11th. Is the 11th Thursday? I think so. Yeah. No, that's the 12th, right? Yeah. It needs to be on the 12th. It'll be due on the 12th. Okay. Or is it the 11th? When are we testing here? We're testing next Thursday because Wednesday is the PSAT. So Thursday's the 12th? Okay. So we're testing on the 12th. I'll make this due the morning of the 12th. I'll change it to the 12th. Okay. You only get one shot at this. Your homework on this module here, this is an external tool, the multiple choice. Your homework allows 2 attempts, but this is a quiz grade. So if you started early, just make sure that you commit to your answer because you only get one shot at this one. It's a quiz grade. All right. And you will have class time to work on this next week. What day? I think Tuesday when you come back. You'll have class time to work on this. Okay. And then I'll activate another optional review. That's free response for those of you who want more practice. Okay. So what do you have the rest of the period to work on? You can work on your homework for 4.4. You can work on this if you're done with that and you want to be careful getting one attempt on this. And if you still owe me other stuff from previous sections, a couple of y'all do, you can work on that. Just remember, if you're ever absent for whatever reason, you're sick or you're skipping or it's late work for whatever reason, it has to be a hard copy. And at the top, just write late or write absent. Okay, if you're absent and you write absent on there, I won't count off the late penalty, which is 30 points. If it's late, you put late up there, and I'll be like, should have got it in. Should have got it in. Okay? Any other comments or questions before I cut you all loose? Yes. Yes, you may. Yeah, absolutely. Okay. We're done. On your mark, get set, go.